In general, we know that the inverse function reverses the rule of original function. Also, for the function to have its inverse, function has to have one important property, which is called one-to-one. We remember this from the pre-calculus class, of course. And just to recall, one-to-one function is also called the injective function, and meaning that the different inputs always gives the different outputs. Like saying, maybe using different words, no two x values share the same y values. And we know that this is not the case for the trigonometric function, since, for instance, and we also have horizontal line test. Yeah, that's, for instance, if I will draw a function sine, too fast. Let's draw sine, maybe just on that small domain. Drawing a horizontal line, for instance, like this, we can see the line intersect the curve twice. That means we have for x sub 1 and for x sub 2, we have the same output y. That means function is not one-to-one. However, we really need the trigonometric inverse function, correct? And I hope we know why. We can have a couple of reasons, but the most important one is without a trigonometric inverse, there would be no systematic way to find an angle. Yes, because trigonometric functions, they define an angle. That's, for instance, sine of y, cosine of y, tangent of y, that y is an angle. Y is an angle. Yes? And then we have the output. That's when we can see we may define y. Inverse sine of x equals to y, since sine of y equals to x. Yeah, that's the inverse notation. That's when we can see this is a nice systematic way to define an angle, yeah? To isolate angle, let's say this way. Okay, that's when we really need an inverse. We know that. And what we will do, we will force trigonometric curves to be one-to-one by restricting the domain. Okay, that's me. Let's see. Let's look at the sine. That means this is the graph of the sine curve. We know this. And what we will do, we will cut the domain. We will just take the domain from the curve from negative pi over 2 to positive pi over 2, including the endpoints. So we can see we only taking that part. That means from now on, when we thinking about the inverse sine, we only thinking about this domain, which actually this will become a range, because domain and range, they interchange for the inverse function. Okay, that means this is the inverse sine function, inverse sine, which we can also call it arc sine. Yes, arc sine of x. Okay, and we can see the output is just between negative pi over 2 to positive pi over 2, and the input is between negative 1 and 1. Domain and range they interchange. Okay, that means we can just think always about the domain. Yes, the angle is just between these two values, and yeah, that's the graph. Okay, that's me. Please, yeah, remember this. Okay, and now I have just the definition. The inverse sine function is the function, yes, inverse sine with the domain between negative 1 and 1 and range between negative pi over 2 to positive pi over 2, including the endpoints. And this is the definition. Inverse sine of x equals to y, if and only if sine of y equals to x. And we can use the arc sine, of course. Okay, and we also have the cancellation property. When we make the composition of the function and its inverse, we always get the argument, the input x, remembering the restrictions. Okay, and now let's maybe do the first exercise. Find each values. That we have to be careful with the domain. Okay, that means inverse sine of of pi over 3. We may see they will actually cancel each other. Pi over 3 is definitely in the domain from negative pi over 2 to positive pi over 2. That's when we can simply use the cancellation equations and we will end up with this. Okay, however, the second exercise, the second part, 2 pi over 3, yes, 2 times 60, 120, that's not in that domain. Yes, we can only go up to, like, theoretically, like the, yeah, I was gonna say fourth quadrant and the first quadrant, but we have to be careful, okay, because we have to keep the order. Okay, that's what we will do. Let's copy this inverse sine of 2 pi over 3. We have to go through the unit circle values. Okay, sine of 2 pi over 3. That's what is the value of the function sine at 120 degrees, 100, 120. Yeah? It's the second quadrant, sine is positive, and it's the same value like for sine of 60. Sine of pi over 3, which is square root of 3 over 2. And now we have to solve this. It's inverse sine of 3 pi over 2. All right, that means now we may actually create an equation, okay? Let's say this is x, we don't know, okay? Inverse sine of 3 pi over 2 equals to x, then I can use the inverse equation, then sine of x equals to square root of 3 over 2. And this is a basic trigonometric equation. Sine for what angle? That's angle, we remember. Sine for what angle equals to 3 pi over 2. And we, of course, know that this is 60 degrees, pi over 3, because this belongs to that interval. That's the domain. We also have, if this will be just the regular equation, okay, I think we will also say the solution from the second quadrant because sine is positive in the second quadrant. But we cannot accept this one since we're really thinking about this restriction. That means this is not part of the solution. That's what I couldn't do this because that will be wrong. I couldn't use the cancellation equation. That means final answer is actually pi over 3. Okay, pi over 3, not 2 pi over 3. Okay, that's we have to be careful with the domain. Okay, inverse sine, done. Now cosine. This is the cosine curve. We, of course, recognizing this is 0, pi over 2, negative pi over 2, and we will do the same. We will restrict the domain to making function 1 to 1. And what we do for cosine, we taking from 0 to pi, from 0 to pi only. Now we interchanging domain and range, or we can also say that the inverse graph is we can obtain by reflecting the original graph reflecting with respect to the line y equals to x, because y is equal to x. We exchanging this. Okay, but this is the graph. Domain is from negative 1 to 1 and range is from 0 to pi. That means angle. When we think about the angle, we can only look for the values from 0 to pi, theoretically the first and the second quadrant. Beautiful. And now definition. Okay, we can also call arc cosine, and that's the cancellation equation. If we really think about the restriction, combination, I mean compound, function and its inverse, we can always end up with, we can cancel out, we can always end up with the argument x. Okay, but we have to make sure that x belongs to this interval. Okay, it's mean now the same thing. Let's evaluate this. Let's check. Okay, that's what we can see. 2 pi over 3. This is also 2 pi 60, 2 times pi over 60, which, where you, 2 times 60. Pi over 3 is 60 degrees. That means 2 times 60 is 120. It's a second quadrant, and I think this is good. We may just cancel out. This will be 2 pi over 3. 120 degrees because 2 pi over 3 belongs to the domain of the inverse cosine. Okay, this one is 5 pi over 3, which is 5 times 60, it's 300, fourth quadrant. That means 5 pi over 3 doesn't belong to the domain. That's we cannot use cancellation equation. I cannot just cancel function and its inverse. Let's actually evaluate. We can copy inverse. And what is the value of cosine of 5 pi over 3? Cosine of 5 pi over 3, I think is, it's like 60 because it's the fourth quadrant. Cosine is positive and it's 1/2 because cosine of 60 is 1/2. And now we may just make a little bit shorter. Cosine for what angle is 1/2? Of course, for 60. Okay, but we can see I can use pi over 3 only because this belongs to that domain. That means this is the final answer, not the 5 pi over 3. Excellent. Yes, you can also practice. You can redo the problems on your own, always. We know that the rule. Okay, and now we have something like this. Try to simplify sine of inverse cosine of 1/3. Let's call it part A. Let's call it part B. Okay, that's we assuming, yes, that we keeping everything in the domain. But now how we can simplify this? That's what we can do. We may try to maybe call it this y. Okay, and I will say sine of y. We have to find out what is sine of y. Now, what we did, inverse cosine of 1/3 equals to y. Now I can switch based on the definition. I can say cosine of y equals to 1/3. Yes, because that's the definition. Now, when we have one trigonometric ratio and the right triangle, we can build the right triangle, we may find all of the ratios and we can see cosine of y is 1/3. Then sine of y will be relatively easy to find. Okay, let's call it the angle y. Cosine is adjacent, right? Adjacent over hypotenuse. That means this is adjacent, 1, and hypotenuse is 3. If this is 1, this is 3, we can easily calculate the third side, the opposite, which will be 9 squared minus 1. Not 9 squared, 3 squared, which is 9 minus 1, and square root of 8. Okay, that means sine will be opposite, square root of 8 over 3, opposite over hypotenuse. Done. And we may say 2 root 2 over 3. Beautiful. Okay, we did this. Nice. Now the same thing. Let's call it the inner quantity y. Oh, too low. We can find cosine of y. That's mean, let's see. Inverse sine of 5 over 7, okay, equals to y. Then sine of y equals to 5 over 7. I'm using a definition of an inverse function. This means since one ratio is given, we can find all the rest of the six of them. If this is y. Okay, sine ratio is opposite over hypotenuse, 5 over 7. Then the third side, which is called adjacent with respect to the angle y, it will be 7 squared minus 5 squared, yes, based on the Pythagorean theorem. A squared plus b squared equals to c squared, and the square root. That's we can have 49 minus 25, and this will be 24. Okay, 24 is 4 times 6, 2 root 6, if I'm correct. Yes, you can, of course, you can always find, because the basic arithmetic is quite challenged. Okay, that's we have all of the sides and we need cosine. Cosine will be adjacent, which is actually 2 root 6 over hypotenuse, 2 root 6 over 7. Yes, 24, 4 times 6, square root of 4 is 2, 2 root 6. Beautiful. Okay, and everything is in the domain. Okay, now tangent. Okay, inverse tangent. That means inverse tangent of x equals to y, if and only if tangent of y equals to x. And we do have the restriction. Okay, and that's the cancellation. Yes, I did it the other way because now we know. And let's look at the graph. This is graph of tangent function. And of course, it's not one-to-one because we have infinitely many x's for the same output, for the same values. That's mean what we will do. We will restrict the domain. The restriction is similar to sine function because it's from negative pi over 2 to positive pi over 2. However, we're not including the endpoints for tangent. Okay, that's when we're taking this. We, of course, interchanging domain and range. Now, instead of range being from negative infinity to positive infinity, the domain, yes, now domain is from negative infinity to positive infinity. And this is arc. Let me use this arc tangent of x. Yeah, it will be quite helpful. One of the important, I mean, everything is important function. And then range is just between negative pi over 2 to positive pi over 2, not including. That means they actually will become a horizontal asymptote. Okay? Okay, so now let's see, evaluate each values. Inverse tangent at 1, we can put x, then I can reverse tangent of x equals to 1. Tangent for what angle equals to 1? Because that's the, yes, that's the angle. Of course, for 45. And I cannot use because this belongs to the for the domain of the inverse trigonometric. We also have another quadrant that tangent is positive, which is the third one. And this one will be 5 pi over 4, but we cannot accept this. Okay, we cannot accept that. We're not accepting this answer. Just to make sure. Okay, the same we can do this one. Inverse tangent of square root of 3 equals to x, then I can say tangent of x equals to square root of 3. Tangent for what angle equals to square root of 3? We all know that is pi over 3. And this is also fine because this belongs to the first quadrant and this is, oh, I was looking at 2. Let's actually find out the values that is actually not the solution because tangent again is positive in the third quadrant and then we will have 4 pi over 3. But we cannot accept this because this one is outside the domain. That's we're not accepting that answer just in case. Okay, just in case. That means the answer is pi over 3. And let's actually use different color because the green I use for not just to a little bit off. Okay, beautiful. Okay, that's when we know the graphs and I also have a secant. Yes, we will not go crazy using this, but definitely inverse sine and inverse tangent, arcsine and arctangent. Okay, that's the secant, that's the restriction, and this is the inverse. That's cosecant. We're just restricting this way and we're taking this part, and cotangent, we're restricting from 0 to pi. Yes, not including, similar to cosine, but not including the endpoints. Okay, and then let's make sure that we know the graphs, but as I said, we will definitely use a lot arcsine and arctangent in the calculus class. Okay, and just some properties. And let's do the last exercise for this quick review of the inverse trig. And we know the reason that we need trigonometric inverse. Make sure that you know. Thank you. Okay, exercise number 5, and we will be done. Evaluating the following expression without using the calculator. That's let's do the same that we just did. I will call it y. Okay, and then we have to find out what is tangent of y. And let's see. Inverse cosine of x over square root of the quantity 16 plus x squared equals to y. Let's reverse. Then cosine of y equals to that ratio. X over square root 16 plus x squared. Beautiful. Now we can build a triangle. Okay, let's try. This is angle y. Cosine is equal to, the ratio, cosine of y. In the right triangle, it's the ratio of adjacent over hypotenuse. Adjacent over hypotenuse. Okay, adjacent over hypotenuse, which is, this is adjacent, and this will be hypotenuse. 16 plus x squared. Okay. Okay, and then we can use Pythagorean theorem to calculate the third side, which is opposite, because we will need tangent is, if you remember, it's the ratio opposite over adjacent. Okay, that's we have to square hypotenuse, right? We have to square hypotenuse, which when we squaring this quantity, we will have just the quantity inside, 16 plus x squared, and minus that quantity squared, which is x squared, okay? And actually square root of this, which we getting 4, okay? That means 4 over x. 4 over x is the answer to the part A. And let's do the same part B. You can pause the video, you can try to do part B on your own, and then you can check later, okay? Okay, let's try. Let's call it y. We're looking for cosine of y. And cosine, let's just do the cosine is the ratio adjacent over hypotenuse. Let's see what we will get. We need a triangle. Okay, that's we can say inverse tangent of x, 9 minus x squared, square root of this quantity equals to y. Then tangent of y equals to x over 9 minus x squared. Okay, let's build the triangle y. That means the ratio for tangent is opposite over adjacent. X over, that's x, and this will be 9 minus x squared under the square root. Okay, that means if this is A, this is B, we can easily calculate C, the hypotenuse, which we can say x squared plus this quantity squared and the square root, which is x squared plus 9 minus x squared. Okay, we can cancel out. Square root of 9, it's 3. Okay, which actually we need cosine. We need cosine, which it will be adjacent. 9 minus x squared, square root of this, divide by 3. This is the final answer. Okay, that's the information, yes, the basic information about the trigonometric inverse function. Thank you.